You've followed a request across the internet. You've learned the protocol it speaks and the languages the browser runs. Now it's time to see the whole machine, how a real web application is actually assembled, from the button you click to the database it touches. And here's why this matters more than it sounds. Architecture is a map. Once you can picture how an app is built, its front end, its back end, its database, its API is, you can predict where the bugs will be before you send a single payload. Great hackers don't attack randomly. They read the architecture, find the trust boundaries, and aim straight at the weak seams. Let me show you the blueprint. Every web application, no matter how complex, is split into two worlds. And the line between them is the single most important concept in all of web security. Here are the two halves. On one side, the front end, everything that runs in your browser, on the user's device. On the other side, the back end, everything that runs on the server that the user never directly touches. The front end is what you see and click. The back end is where the real decisions get made. And between them runs a line called the trust boundary. This is the idea that separates people who think they can hack from people who actually can. Everything on the front end is under the user's control, which means it can never be trusted. Anything the browser enforces, a hidden field, a disabled button, a price calculated in JavaScript, a validation check, the user can simply change. Real security has to live on the backend, on the far side of that trust boundary. Burn this in now, because 90% of the bugs in this entire series come down to a developer trusting something on the wrong side of that line. Let's zoom into the front end, the client side. This is the HTML, CSS, and JavaScript we covered last episode, delivered to the browser and running on the user's machine. Its job is presentation, draw the interface, collect input, and make the experience smooth. Modern frontends can be very sophisticated, whole applications written in frameworks like React, Angular, or Vue. But here's the thing, every beginner has to unlearn. None of it is secure, because all of it is yours. When you visit a page, that code is downloaded to your device, where you can read every line, watch every request, and change any value before it's sent. A price view set to $9.99. You can edit it to 0. A button that's grayed out because you're not an admin. You can re-enable it in one click. A check that says only proceed if valid. You can rip it out. This is why client-side controls are suggestions, not security. They improve the experience for honest users, but to an attacker, they're just editable text. The front end is where you look for clues, hidden fields, commented out code, API calls, secrets accidentally shipped to the browser, but it is never where the real defenses live. Read the front end like a treasure map, not a wall. Cross the trust boundary, and you reach the part that actually matters, the backend. This is where security either happens or fails. The backend is the code running on the server, out of the user's reach. When your request arrives, this is what receives it, and this is where every decision that matters gets made. Who are you? That's authentication. Are you allowed to do this? That's authorization. Is this data valid? That's validation. What should happen next? That's the business logic. The backend is written in server-side languages, Python, Node, PHP, Java, Ruby, Go, usually inside a framework like Django, Laravel Express, or Spring, which handles routing, sessions, and database access. Because the backend is the real gatekeeper, it's also where the highest impact bugs live. If the backend forgets to check authorization on an endpoint, you get broken access control. You can reach data or actions that aren't yours. If it trusts input it shouldn't, you get injection. If its logic can be tricked, you get business logic flaws. Here's the mental shift. The front end shows you what the developer intended to allow. The back end is where you test what they actually enforce. And those two things are different far more often than they should be. Every serious finding you'll ever report lives back here. Behind the backend sits the database, the app's long-term memory, and very often the ultimate prize. Everything persistent lives here. User accounts, passwords, orders, messages, payment details. When the backend needs to remember or retrieve something, it sends the database a query, a command in a query language. The most common is SQL, used by relational databases like MySQL and Postgres, which store data in structured tables of rows and columns. There's also a family of NoSQL databases like MongoDB that store data more flexibly as documents. Either way, the pattern is the same. The backend builds a query, often using pieces of your input, and asks the database to run it. And that's exactly where one of the most famous vulnerabilities in history is born. If the backend takes your input and pastes it directly into a query without care, you can break out of the data and inject your own commands. That's SQL injection, and it can hand an attacker the entire database. The database is why we hack. Almost every attack path, sooner or later, is trying to reach the data in here. So the front end and back end live in separate worlds. How do they actually talk to each other? Through the most important and most attacked layer in modern web apps, the API. An API, application programming interface, is the messenger between the front end and the back end. Instead of the server building whole pages, the front end makes focused requests to specific backend endpoints. Get my profile, update my email, list my orders, and the backend answers with pure data, usually in JSON format. The most common style is REST, where each endpoint is a URL, and you use HTTP methods, the GET, post, put, delete we learned last episode, to act on it. So a request might be get/API/user/42. Now, why do hackers love APIs? Because they are a massive and often underprotected attack surface. Every endpoint is a door. Developers frequently secure the ones the frontend obviously uses, but forget the ones it doesn't. Change that user 42 to user 43 and you might read someone else's data. That's an access control bug so common in AP is it has its own name, Bola. Send an extra field the form never showed, like role equals admin, and you might escalate your privileges. That's mass assignment. A P is also tend to expose more endpoints than the app visibly uses, waiting to be discovered. When we reach the API and cloud module later, this is where a lot of real bug bounty money is made. Let's peek at how the backend code itself is organized, because structure gives you leverage. The most common pattern is MVC, model, view, controller. The model is the data and how it's stored. The view is what gets shown to the user, and the controller is the logic that ties them together. It receives the request, decides what to do, and sends back a response. You don't need to write MVC, but recognizing it helps you guess how an app is laid out and where its endpoints live. Zooming out further, whole applications are structured in two broad styles. A monolith is one big code base where everything runs together, simple, but one weak spot can expose a lot. Microservices break the app into many small, independent services that talk to each other over the network, flexible, but every connection between them is a new place for things to go wrong, like server-side request forgery. You don't need to master software architecture. You just need to recognize these shapes, because the moment you understand how an app is organized, you stop guessing and start knowing where to look. One more distinction, and it defines almost every modern app you use, how the page actually gets built. This is the difference between the old web and the new one. There are two big ways to build a web app, and they behave very differently. The traditional way is server-side rendering, often called a multi-page application. Every time you click a link, the server builds a whole new HTML page and sends it back, and the browser reloads. Think classic websites, each action is a full round trip. The modern way is the single page application or SPA built with frameworks like React, Angular and Vue. Here the server sends one shell of a page and a big bundle of JavaScript, and from then on that JavaScript runs the whole show in your browser. Click something and instead of reloading, the app quietly calls an API in the background, gets back JSON and rewrites the page using the DOM, no full reload, just a smooth update. Almost every app you use daily works this way. For a hacker, this changes your approach. SP as are API driven, so the real action isn't in the page source, it's in the flood of background API calls, which you watch in your DevTools network tab. They ship a lot of JavaScript, which often leaks endpoints and secrets you can mine. And because so much logic moved into the browser, client-side bugs like DOM-based XSS become even more important. Know which kind of app you're looking at, and you know where to point your tools. Let's assemble the whole machine in one picture. You, in the browser, running the front end. You take an action, and the front end sends an API request across a trust boundary. On the server, the backend receives it, checks who you are and what you're allowed to do, runs its logic, and queries the database for whatever data it needs. The database answers, the backend builds a response, usually JSON, and sends it back across the boundary. The front end receives that data and updates what you see. That's it. That is every web application you will ever test. From a tiny blog to a banking platform, the same handful of parts arranged the same way. The apps get bigger and the pieces get fancier, but the shape never changes. And now you can see it. So why did we map the whole architecture before touching a single exploit? Because this diagram is your attack surface, laid out in advance. When you approach any target now, you're not staring at a mysterious website. You're looking at a front end you can read for clues, an API, you can probe endpoint by endpoint, a backend you can test for the checks it forgot, and a database you're ultimately trying to reach. And running through all of it is the one line that decides everything, the trust boundary. Almost every vulnerability in this entire series is a story about that boundary. A developer who trusted the front end, trusted the input, trusted a request that came from the wrong place. Broken access control, injection, SSRF, business logic flaws, all of them are just different ways of crossing a line the developer assumed you couldn't. You now hold the map. From here, we start learning the specific moves, and every one of them will land somewhere on this picture. Let's lock it in. 1. Every app splits into front end and back end, divided by the trust boundary. 2. The front end runs in your browser and can never be trusted. 3. Client-side controls are suggestions, not security. 4. The backend is the real gatekeeper, authentication, authorization, logic. 5. The database is the prize, reached through queries. 6. AP is connect the two and every endpoint is a door. 7. Recognize MVC, monoliths, microservices and SP, as to know where to look. And 8. Almost every bug is a developer trusting the wrong side of the boundary. Clean shot this. You now understand the whole machine, which means you're finally ready to start breaking it. Subscribe because the foundations are nearly complete and the attacks are close. In the next episode, we cover the last piece of groundwork, encoding, hashing and encryption, base 64 hashes, and the crypto concepts you'll run into constantly once exploitation begins. It's shorter, it's essential, and it'll save you endless confusion later. Drop a comment. What part of the stack do you most want to attack first? See you in the next one.